So, good afternoon, and welcome everybody, and thank you for taking the time to come in here. Inside and out, from a sustainability point of view, and that's what I'm going to be hopefully talking about. So, I'm not Mike Gallagher. Unfortunately, COVID has struck, and he's having to stay in the US and couldn't travel. So, I'm covering for him today, and I'm really looking forward to hopefully talking about some of this content with you guys. If you have questions, just jump in and ask. It's pretty informal, and you'll see us just rattling through. So from an inside perspective, we have, as a business, been around since 1955, working with the telecoms industry for a very long period of time. We pride ourselves on being able to look at that end-to-end piece. And over the last few years, and you'll see hopefully from some of the content, we have been working religiously to try and figure out how we take that engineering expertise. We're engineers. We're all engineers in this room, and we love what we do. And we're trying to design solutions that hopefully try and fix these little problems. And from an allocation perspective, on the screen, there's an average. It really doesn't matter how you slice and dice that pie chart, really irrelevant. But there or thereabouts, it's an average of seeing how that split with energy occurs. The most of it going to the IT equipment. You've got lighting, you've got the UPS transformation piece, which we're working on at the moment. You should see some more stuff from Panduit coming forward in the future when it comes to UPSs in the data centers, and the efficiency that will be there or thereabouts. And then the air movement, that's a free spirit. It goes where it wants, when it wants, and we can't let that happen. We've got to manage that and control it, and that's what we are good at. And then you've got the cooling aspect as well. So all in all, there's a huge piece of that pie that is something that we've been dedicated to, and now we're trying to look at how we can try and improve upon the aspects of what we bring to market that drive that. But lighting, I mean, we don't make lights. We have nothing whatsoever to do with that. However, when you look at the luminescence within a facility, it's been occurring now for many, many years. You know, years and years ago, they were all black cabinets, they were all dark-colored cabinets. And we actually wrote a paper about 15 years ago, and we started to look at the concept of, hey guys, let's not go down this particular road. Let's think about a different way of approaching it. And it's very, very simple in the sense that if you go with white cabinets with certain configurations, and I've taken the middle of the road. Would you believe 80% is the middle of the road? Well, in this case, it is. If you look at the luminescence of light reflecting or light reflectance from various surfaces, white cabinets are definitely the solution to be employing when you're looking at a comms room fit-out. You know, the average, whether you're a hot or cold aisle separation, if you've got a cold aisle containment, hot aisle containment, if you go down to a VED, vertical exhaust duct or chimney, and you have that configuration comparing white to black, you could be looking at 180% improvement in light illumination compared to a black cabinet. So it absolutely is a no-brainer to work with the lighter colored reflective surfaces. And how do we achieve that 25 to 30% in terms of energy savings? It's very, very simple. You install fewer light fixings. And the fewer you install, the more money you save. Or you reduce the lux value of the lighting within the actual environment. So that lux value, rather than running typically at your 300, may be at now 150 to 100. So all of these incremental little steps add to saving energy, and that's the key thing. It's a small value, 3%. However, there is work to be done in terms of improving the actual savings that can be achieved, I should say. And when you get to the airflow aspect and the cooling aspect, well, you clump those together, you're at 37%. Now, the overall consumption is reasonable in terms of that particular pie chart, and it's something that we need to aggressively go at. And it's what just about everybody downstairs is going to be involved in doing, controlling the air and managing how those efficiencies typically are driven. And we've come up with a very, very simple formula in ourselves. And you know, it's something that we've worked on over the years. Look, we're manufacturers. We bend metal for a living. And we bend metal to control air, that free spirit, in the facilities that we all run and love. And we've kind of come up with this acronym that if you are able to control the hot aisle, cold aisle, when you're at kind of 0 to 8 kilowatts, separations in the past, they worked really, really well. As you go north of that 8 kilowatts, you're starting to look at controlling in terms of the airflow. So you've got a cold aisle, you've got a hot aisle. When you start to go north of that, you're at 40, 50 kilowatts, you're probably looking at hot air containment. Now, controlling that in itself is really, really critical. And by doing that, together with, direct air, and, we have looked at various aspects of the active components that are out there. And some of these breathe side to side, some of these breathe front to rear. Thank God the majority are front to rear, but we still do have a lot of equipment that goes side to side. And what you don't want to be doing is having hot air exhausting into the intake of the actual chassis that's living or breathing next to it. And that's a no-no, because the more you do that, the intake value of that particular hot air, there are certain metrics that you can look at what is then achieved. So if, for example, we all know you can be running equipment nowadays at 27 degrees, quite happily it will run. However, if you increase that by 30 degrees, you are going to have a 50% degradation in terms of the lifespan or the running of that particular piece of kit. That's something we don't want in any facility. And that is a problem. So we have, very, very simply, looked at how we can control that air so that it's not doing what it wants to do. We want it to flow from the side round to the back and exhausting out into the hot aisle. It's a very simple concept, and all we do is bend metal to control that flow so that it goes where we want it to go. And that's critical, because the more we do that, the better the lifespan of the equipment in the actual facilities that we're running. And then sealing every gap. It's the simplest of concepts, but from our perspective, we've spent a lot of time looking at, how do we manage this air within the actual facility? And to enable us to do that, we have built 3 thermal labs in our R&D facilities. We have flow test bench measurement equipment, and within the actual thermal labs, all 3 of them, we have the ability to create whatever scenario we're looking to try and achieve. And this is critical, because we make it, we test it, we bring it to the marketplace, and it has to achieve exactly what you want it to achieve and what we want it to achieve. And within these environments, we've created so many different scenarios, and we've actually, in one of the chimney thermal lab, we have about 300 data points measuring temperatures on a single cabinet. In the data center thermal lab, we have about 20 cabinets, each with 300 temperature measuring points. So this thing is measured up to the eyeballs. So we know exactly what's happening where, and how. And we've noticed that it's a very simple concept, but within a facility, if you leave an RU of blanking space in a thermal environment, you basically will lose efficiencies of about 40% from a cooling perspective in that space. So the moral is, always blank off. Don't think, oh, I'm going to be putting some equipment in here in a week's time, I'm just going to leave it, because you're throwing money down the drain, which is not where you want to be. If you're at 13 RU of blanking space because you've got a chassis coming in, efficiency in terms of cooling drops within that space by about 51%. These are stats, these are measured stats that we have calculated. So, it's absolutely critical that you do the simplest of things and do them well. And then monitoring, measuring. Everything about that is key, because, we run around the place, we're on our bikes, we're on Strava, we're running around, we're collecting our dates and times. We're golfing, we've got our pros measuring our distances. We measure everything, and it's absolutely key that we do the same within this facility environment, because that gives us the ability to detect what's going on. And we as a manufacturer are doing that now in terms of some of the environmental characteristics, I should say, that we are seeing in terms of how we produce and make goods. So combining all of those, we believe putting all of that together can save you about 40% in energy of that 37% bracket that was mentioned earlier on. So it's simple. It improves that cooling effectiveness, which is key. It mitigates that hot air recirculation, which is what I was trying to get across in this particular slide. Because if we can control the hot air and manage and make sure that the equipment is getting that 27 where it needs it, we certainly don't want it to be getting anywhere near 57. That's a no-no. And we have measured exhaust temperatures on chassis that are spun up and driving, and they could be easily at 57 to 60 to 65. So it's key that we don't let that happen. You improve the longevity of the equipment that's in that facility and avoid overcooling. All of these little aspects come together to make sure that you're running that facility as well as you possibly can, which is absolutely key. So next, what I thought I would do is look at this particular facility, and this kind of, it's an MTDC, it's in the US, and it's one that we kind of did some work with a few years back. They had a hole, typically, and it was performing reasonably well, but they had a few concerns in certain areas of the hall, and you can see that in the top left-hand on that particular screen there. So what we're able to do is, measure and look at the actual facility in terms of its air pressure and its temperature flow above and below. And that's really, really important because by measuring, you get to understand what's going on. And we can then calculate ways of improving and mitigating to get better efficiencies out of this particular environment. And what we were able to do was look at, they had about 20 crack units in this particular space. 13 of them were on, 7 of them were off. We looked at this and thought, well, hold on a second, let's measure, see what sort of baseline we can collect. And straight away we noticed something odd. They were overcooling, so it was somewhere in the region of about 19, but then in the top left-hand corner of the facility, there was a huge pressure drop, which they were seeing, and that was where their high-density compute was actually sitting. And that's a problem, because you want an even distribution. You start to have pressure drops, you're creating inefficiencies. And that caused a huge problem for them in terms of the efficiencies that they were seeing. And as a result of that pressure drop, they were having to overcool by ramping up the actual fan speeds. So the average fan speeds in those top left-hand corners was somewhere in the region of around 95%. Which was too high. You don't need to be at that level. So with this particular system, we were able to create a baseline, look at what was going on. We were able to redistribute floor tiles and actually spin up all 7 cracks that were switched off. We reduced the fan speeds. We could have got them down to about the 45% mark, but they wanted to have a degree of contingency in there. So we actually created around 62%, as it says on the slide there. And overall, we were able to save these guys a total power consumption saving of about 38. In terms of kilowatts. Now, we could have got them closer to the 50, but they were happy with 38, so that's great. From their perspective, they achieved what they were looking to try and achieve. But we wouldn't have been able to do any of that without simply collecting pressure and temperature data. It's as easy as that. And by doing that, making some simple, correct decisions, moving floor tiles, spinning up cracks, and hey presto, they had all of those savings. So it's really, really simple, it's low-hanging fruit, and it's not hard to do. So that's kind of inside the data center. There's lots of other great things that we're able to do and facilitate and help with. But what we are now being asked a lot about is, well, what's going on outside? What's going on in Panduit corporate that's driving you forward in terms of a sustainability point of view, and we are engineers. From our perspective, there is so much more that we could be doing. We're nowhere near where we want to be. We are way behind internally, but we're very excited about the roadmap and the future in terms of where we're driving. It's almost like that never-ending drive, that never-ending trying to achieve exactly where we need to go. So from our perspective, you know, those guidelines from a supply chain point of view, you know, we've got to look at how we, you know, energy reduction goals are key. That carbon footprint, waste reduction efforts, innovation. And what I'm going to try and do is share with you some of our internal guidelines and our policies that we're currently working to at the moment from an infrastructure perspective. So Andy is his chairman, he's the top guy in the organization, and this is his project, so he's driving that. So from our perspective as a business, we have the right champion to try and push this forward. It's going to cost a lot because we have lots of different manufacturing centers all over the globe, but it's something that he's bought into. So he's got the board alongside with him, bought into this whole process. And we'll hopefully try and walk you through some of what we're trying to do. Vision, mission, strategy. It's as simple as that. We have the vision to reduce our footprint. We have the strategy. It's there. The mission comes from us, the people in this room who are driving what you need us to be doing, the people from our perspective who are constantly looking at ways that we can try and innovate and improve. The strategy consists of that very simple footprint. You know, we're trying to control our footprint, support the circular economy, eliminate the waste, and drive sustainable innovation in terms of everything new that we bring to the market. It's as simple as that. We don't want to make it complicated. We just want to have a very, very simple strategy that we can implement. Now, some of the highlights from our perspective as a business have come from, you know, our largest manufacturing facility in terms of Costa Rica. Now, that in itself, we were able to achieve carbon neutrality in 2014. When I went to that plant in the north, that was our biggest facility. We had like 1,000,001 football pitches that surrounded this facility. It was just amazing. We had basketball courts, we had football pitches, we had baseball courts. It was sports surrounding this particular facility. But we made a decision to can all of that, and there's some great local gym facilities for the huge numbers of people we employ in that area. But Costa Rica was going through a process of, you know, huge deforestation. There was loss of indigenous species. So the plant team decided to work with a local ecology group, and all of that surrounding land was turned into a tree nursery. Every single last bit of it into a tree nursery. And we are now growing and facilitating trees that can be grown and redistributed into the forest of Costa Rica, which is really, really important from our perspective as a business, because it helps us to feed back into that particular cycle of things that are going on around the world. So tree planting is absolutely key, and it helps us with our carbon reduction guidelines. We're maintaining the standards globally that we're working to in terms of ISO, which is key. There's a new project that we're working on as a business in terms of one of our facilities in Lockport, and as we cycle through these particular aspects, we need a new roof on this production plant. That's going to cost us millions to replace. In the process of replacing that roof, we're going to be replacing it with all photovoltaic cells, and we're going to be generating a huge solar farm just around the factory area. Now, that's going to allow us to generate 33% of the energy that's going to be coming from those particular green generation techniques into the actual factory itself, 33%. So the payback time is going to be significantly quicker than some of the other aspects that we're working to. So regulatory compliance is going to be obviously very, very important. So from our perspective, we're on that roadmap where we're looking at every single factory and plant that we have and looking at ways and innovative ways that we can change and drive that sustainability agenda. So if I hop back to Costa Rica, because of what we're doing in there and the size of the plant, we generate about 20 tons a year of biodegradable waste, which then goes back into the tree planting area around the whole farm. So it's an exciting project, and it's one that we're constantly driving to. Reducing energy is absolutely key. Electricity, fossil, water. Increase in terms of the percentage from renewable construction is absolutely key. Waste to landfill, we have to keep on driving that to reduce that percentage and also drive hazardous waste down and also improve the recycling aspects. And from our perspective, those new products that we try and develop have to have a future eye on where we are going into the actual marketplace. So the ESG initiative, there are 6 key tasks that we're working to as a business. We've got 7 in total. The 7th one is the future. And those 6 are very, very key in terms of how we're going to be driving ourselves and basically putting metrics on us as a business to keep on improving. Because the funny thing is, every time we now go for a tender, we are being pushed and asked to show exactly what our capabilities are when it comes to ESG. And that's great, because our customers are driving us, our partners are driving us, and we have to drive ourselves. So we have to keep pace with that. So the 6 are basically the base materials that we use, product manufacturing, transportation, reuse, recycling, and disposal, and then, of course, the future. So what I thought I would do is look at some of these in closer detail. So by looking at the base materials, let's be frank here. Especially on the copper side, it's a pretty dirty business when it comes to what we're doing. We're mining copper, we're drawing copper, we're producing copper cables. Now, environmentally, that's just shot to bits. And we have to look at ways of how we go about improving that, and we can. And we can do that by innovating and developing slightly different products. So 6-7 years ago, we developed a 28 AWG patch cord. By going with a 28 AWG instead of a 23 or 24. By the way, American wire gauge is AWG. The larger the number, the smaller the diameter of the copper conductor in that particular solution. So a 28 AWG conductor has about 60% less copper than a 24 AWG conductor. So by trying to push the market and push the standards teams, which we have been doing, to accept these new solutions, then we are able to use less copper in terms of how we generate these transmission characteristics. We also, a few years ago, produced a 28 gauge AWG Cat6 cable. Technically, that was restricted to 50 meters in terms of length. That was a problem from a design perspective, so it never really took off. But the technology and the ability to make it still exists, and it could be brought back to life again. So we're constantly looking at those interesting ways. We have a new solution that's potentially on the horizon, which is the Verimatrix HD. We're thinking about that launching in about Q3, 4 in EMEA. This is launched in the US already. We've looked at ways of reducing the weight of that particular cable using less plastics in that particular cable so that we can reduce the diameter as well. So we get a benefit of a smaller diameter cable, a lighter cable. It takes up less space, and you'll see how we impact some of that going forward in the future. But we have to look at our manufacturing processes, and part of that is EPD, HPD, environmental product declarations and health product declarations. So as a manufacturer, we've bought into independently having all our product sets certified so that we look at the life cycle of how we go about making this particular solution set. So it's not just throwing a cable onto the marketplace, it's looking at cradle to grave in terms of the cumulative energy on how each one of those particular solutions are made. And you can see that I put this up here on purpose. That's the middle there is the 28 gauge Cat 6, which is the one we made a few years ago. And you can see from a materials perspective, significantly less copper. So environmentally, it's a lot better. However, distance-wise, it was a bit of a problem. So we are focused on measuring, and that's the key. Not only do you measure when you're in the data center so that you can make intelligent decisions, you have to measure in terms of the materials and the effect the materials that we use have on your fantastic facilities. And that's what we do on a daily basis. So we have independent confirmation that this is exactly the processes we're working to. We are also looking at, as it says on there, keeping 100% recycled copper and, the use of ethylene, propylene, fluorinated ethylene, propylene to an absolute minimum. And that's also 100% recycled in our manufacturing processes. We do need that. We can't get away from it at the moment in terms of materials technology because it helps us formulate the jackets on the cables that we make from a fiber and also from a copper perspective. So there are hazardous materials in terms of our manufacturing processes, but we collect every single bit of that material and it's recycled and put back into that process so that we have complete control. If you look at transportation, again, that forms a huge part of the EPD, HPD process in terms of measuring the transportation. So we can make it, but we have to transport the raw materials into our factories. We make, then we have to transport out of our factories to your good selves. So we have that measurement technique so that we can look at the energy involved in the energy that's contributed into the actual transportations of the product set. And that's key because if we can make our products smaller and lighter, we use less space. From a palletizing point of view, it's cheaper and better to transport. The cheaper bit's good for us because it helps our bottom line. But if we take up less space, it's also good for the environment because this particular new cable that we've developed, as you can see here, is 23% lighter, 80% increased pallet quantity. So with the older solutions, rather than getting 200 reels on a 20-foot flatbed, we can now get 360. So it's more efficient from a transportation point of view. And that is key in terms of our mindset. So everything we're thinking about, we're looking at ways of how we can improve, how we can get the packaging down. We've just brought out a new range of cabinets, the Flex Fusion. Sounds minute, 50 grams less packaging, but if we're making thousands of cabinets every year, it mounts up. So everything we engineer, we're looking to measure how we can improve and get lower in terms of the packaging and the single-use plastics that we're using. Reuse, which is also a key aspect, and we're suddenly, believe it or not, now being asked by our customers, how can we reuse what you're selling us? We don't want to throw it away. How can we reuse it? So we're having to think about new and interesting ways of how we can, have our technology be used again. So our jacks, we've re-engineered so that they can be re-terminated up to 20 times, I should say. The fiber connectors, 2 to 3 times, because of this index matching gel in there. So 20 times allows you to take that jack, repurpose it, and reuse it again. We can also offer pre-terminated solutions, which allow you to take the loom, reuse that loom again. So it's all about interesting ways that you can go about taking a product, not leaving it in the ground to be thrown away or recycled, but reuse it again. We've just come up with a new solution that we're working on with a really exciting company in France. It's called One Mode, and that is a solution in itself that we saw the benefit of this as it came out of the research lab from the university straight away. Multimode fiber has a variety of different paths that you can take in terms of lighting up the light to get it from point A to point B. Single mode has one path that it takes, but multimode fiber from days gone by in terms of OM1, 2, 3, 4 would have about 300 plus different modes that it could characterize. That fiber is now being ripped out and being replaced because the drive now is single mode fiber. People are looking to drive single-mode fiber because you can get increased bandwidth up to 100 gig quite happily, and you can get the distance. So this particular box is a series of filters that allows us to find the monochromatic mode of light within multimode fiber. So we can turn all your old multimode fiber, OM1, 2, 3, 4, 5, and we can turn that into a single mode style characteristic fiber so that you can run 10 to 100 gig of traffic on OM1 fiber up to about 800 meters. If you put a box on both ends, you can go kilometers. So we're trying to find ways of saying, hey guys, don't throw it away, don't waste it, let's relight it. We will get you the technology that can find that single mode of light to travel down your path so that you don't waste your fiber. Now, that sounds counterintuitive because I make single mode fiber and I want to sell new single mode fiber. But it's a technology that we have to think about because there are backbone cables that are run through environments that you don't want to go ripping out and replacing because they might be old, they might be inducting. You don't want to go ripping up roads. So if you can relight and repurpose this fiber, one, it saves you time, could save you money, and hey, look, you're not throwing stuff away. You're going to reuse it, which is exactly what we need to be thinking about. There's lots of presentations that have been talked about in terms of the circularity of what we're trying to do here. And this reuse element of it, I think, is really, really important. And that's the future. So we're constantly working with universities and trying to find new and interesting ways that we can repurpose what it is that we do. The recycling and disposable element, that's key as well. Again, EPD, HPDs, they're hot on our trails because they are tracking, 5 minutes. They are tracking, I'm almost at the end. They are tracking exactly what we have to do as a business. And that's really, really important. So, we're trying to keep that copper element to an absolute maximum in terms of recycling. And you can see here in terms of the effect it's having. You can recycle the copper within the actual cables. You're able to landfill some of the actual plastics, and you can incinerate some of them. So when you go to combined heat and power plants, you have the ability to have power being generated, which is really, really important. So as a business, we are looking at ways, and we have found a way of looking at all our single-use plastics and changing the packaging style within our plants. So we've had to reinvest and have new plant machines who will now tie our patch cords, our pigtails, our trunks, our fiber trunks, not using plastic material, but using more recyclable material. So that recycling and disposable element is absolutely key. We're working with our partners to actually look at the palletization of our cabinets, the reels that we ship in terms of our products and services. How can we collect that and get that into chipping services, get that into combined heat and power plant services so that they can be burnt and reused in different ways? So that forms a huge part of the value add that we're bringing to this particular aspect. And then I think just about the second to last slide, we have been doing this for a number of years, and the concept is pre-configuration is absolutely key now. There are some pitfalls with it because if needs change, if the requirements change in terms of the rack layout, you've built a system that is not going to work to where you want to go. But there are huge advantages, because if that conversation piece can be worked through so that everybody's on the same page. We did a project with a customer, and they were just looking to have 600 links in. The first project was the picture on the left-hand side, and you can see the amount of waste that was generated. The next project, the customer said, you've got to do better than this. Look at all this crap that is going into my waste disposal at my data center. So we said, okay, we'll pre-configure this, and we'll look at that element. So we got rid of all the reels, and we were able to get them in just some cardboard boxes, which we were able to take away and recycle. And we got an 80% reduction in terms of the waste. So by looking at how we can build cabinets, pre-configure those cabinets in our factories with PDUs, with the right copper fiber infrastructure, you can start to reduce the amount of waste that goes to site. We can start to improve the efficiencies of our transportation so that we're packing a lot more into a single space to ship it out to your good selves. So, that waste reduction example is there, and it's very low-hanging fruit. So effectively, in conclusion, coming up to the end, it's not heavy lifting to do a lot of these particular elements. They're very, very simple things that can be done. Blanking panels, hugely cheap, hugely efficient in terms of air control. waste recycling and collection. Very, very simple, very, very easy to do. So the future from our perspective is looking at how we can find these interesting technologies, for example, one mode, that we can repurpose to drive the reutilization of product that we have made and maybe shipped 10, 20 years ago, but let's bring it back to life so that it's almost like as it was first installed. So that's what we're doing as a business. We're trying to help internally, but key, we're also looking at what we're doing externally to you in terms of driving your businesses forward. So that's me. So thank you very much for your time today. Any questions?
Thank you so much.
Oh, well, thank you.